congratulations, you've made it through lecture 2, and we have covered an awful lot of ground. I'm aware was really a tour de force, but with the supplemental material and also with practice on data camp, you should be hopefully be able to process this, maybe not in a week, but in the next few months, and get comfortable with this. So today we've covered string operations and DNA analysis, string slicing, string methods, and I think this is really important for the biological context of reading and working with sequence files and sequence data. We've learned some very important key concepts in programming, conditionals and decision makings, logical operators, Booleans, data, and error. And we also worked on error handling, and we dealt with dictionaries and data organizations. So key value pairs, translation, we can use this for translating DNA to RNA to protein, for example, things like that. And finally, we also covered file handling and file input and output using the with open context manager, and we delved into faster files. So I think this gives you a good grounded overview. And now it's really, the ball is with you to practice this and digest it and learn it at your own pace. So what you have learned today, if you get comfortable with it, you can start building a lot of stuff by yourself. You can, expand on this OR finding program that we built, and for example, find all the ORs and then just filter out the longest to find the one that you really want. And there's all sorts of other automated DNA calculations you could do. You could make your own little DNA strider program very easily now. So practicing this for your own applications would be really, really useful to enhance your skills. And yeah, so I hope this was informative. Before I leave this, I just want to point you out to a few more resources. And one thing that you should definitely check out as budding bioinformaticians is this library BioPython. We talk about open source and libraries and imports in the next lecture, but have a look at this already. This has got a lot of functions and a lot of tools to deal with DNA, also with publications, with text, but anything you need for biological sciences. So this is a very useful collection of methodology in Python to deal with biological data. So check this out. There's beautiful docs and tutorials and a cookbook. So this is really for you to play around with. There are other essential bioinformatics libraries, and we'll deal with them in due course. Pandas is probably the most important one, and also visualization. So this will come next in the next course. And yeah, I think start working with databases, start pulling out data. Now you have learned some of the key resources and key ingredients to build meaningful programs to deal with this sort of data. And we've just scratched the surface. I'm aware of that. That's all we can do in a 1-hour lecture. But now I hope I have given you sort of the starting point. I've just lit the fire under you that you can now go and learn yourself. Okay, and yeah, I see you in the next lecture.